rocketing along at 1,000 miles an hour. The plane is out of control. You're spiraling toward the Earth. For most people, it's a nightmare. For a test pilot, it's a way of life.
What we do is we take the aircraft or the weapon system or the combination of the two, and we put it through its paces for the first time.
There are more opportunities to make catastrophic mistakes in this line of work.
Test pilots propel 10 tons of steel and 4,000 gallons of jet fuel through the sky at speeds of more than 1,000 miles an hour. They do it every day, at every angle, in every circumstance. They push state-of-the-art technology beyond known limits, putting years of research, millions of public dollars, and even their own lives on the line.
Somebody's got to do it for the first time, and that's our job.
Imagine you're breaking the sound barrier. 500 feet off the ground, 800 miles per hour, and cheating death every second of the way. It takes special individuals, people who are ready to face the unknown and take themselves and their plane to the limit. Risking it all, test pilots try what's never been tried, fly what's never been flown, putting their lives on the line to push the limits of aviation and ensure our air superiority in the future. At Eglin Air Force Base on the Florida Panhandle, professional test pilots are doing some of the most extreme testing done to airplanes.
My name is Major Troy Fontaine. I'm the chief test pilot in the F-15E at Eglin Air Force Base. We take the aircraft or the weapon system or a combination of the two, and we put it through its paces for the first time. Somebody's got to do it for the first time, and that's our job.
At 37 years old, Troy has logged thousands of hours in over 25 different aircraft, flying as both a fighter pilot and as a test pilot.
A fighter pilot very much is an attitude, a killer instinct. You need to turn that off a little bit when you become a test pilot, and sometimes that's hard, very hard in my case, as opposed to going up and killing somebody. The mission is to take an airplane up and do something with it that nobody's ever done before.
This mission is to fly with laser-guided bombs that have never been used on the F-15.
This is a GB-27. It's a 2,000-pound laser-guided bomb. And we're getting it certified on the drop them off of the F-15E, the Strike Eagle.
The F-15 Strike Eagle is the latest version of the F-15 fighter, the workhorse of the Air Force for the last 25 years, while a regular F-15 is designed for air-to-air combat. The Strike Eagle is capable of both air-to-air and air-to-ground missions. The GBU-27 was designed to ride inside the belly of an F-117 stealth fighter. The challenge for Troy and his team is to carry the bomb safely in the extreme wind conditions on the outside of the Strike Eagle. First, Troy has to brief his crew on the dangerous mission.
Out of control. Let's talk about that for a second.
A chase pilot in an F-16 will follow Troy every step of the way, both to note the effects of the wind on the bomb and to help out in case of an emergency.
It looks like we're departing the airplane if something goes wrong. Try and be a walking, talking altimeter to us.
Every year, pilots are killed when they push their planes beyond the limit and lose control. With an untested weapons configuration, there's no way for Troy to know how the plane will respond. If he becomes disoriented and can't read his instruments, his chase pilot will have to warn him if he's getting too close to the ground.
Remember, try and keep, as a chase pilot, try and keep the airplane, the spinning aircraft at that point on the horizon. All right, so that you've got an accurate altimeter to us. If I'm not responding to you, there's a chance that I'm kind of overwhelmed by events. So try and get my attention. Use first names, all right? Troy, you're in a right spin. What I want to do is if we have imminent signs of recovery passing through 10,000 feet, we'll hang with the aircraft till 6. At 6,000 feet, what I want to hear from you is Troy, eject. Troy, get out of the airplane. Use my first name to get my attention. Okay, let's not use the bail out over the radio. All right, and at that point, we'll give the jet back to the government. The anti-G suit is used to basically pump blood back up into our brains. It doesn't make us any smarter, but it's under high accelerations, high Gs, the blood drains from your brain out of your head and pools in the lower extremities, mostly the liver and your upper legs.
Shouldn't have that big sandwich for lunch.
Yeah. Is that your G-suit?
In sharp turns and steep dives, pilots experience gravitational forces many times that of gravity on Earth. Pilots can black out at the controls when this pressure causes the blood to drain from their brains. Known as G-lock, this poses one of the greatest physical challenges for the fighter pilot.
What happens is there's bladders in the G-suit and the hose hooks into the airplane, and as you pull G's, it senses that acceleration. It inflates the hose, inflates the bladder, pushes against our livers and our upper thighs, and pushes the blood back up into us. It gives you about an extra G of tolerance. So if you normally black out at 8 Gs, now you can pull 9.
G stands for gravity. In a 9G turn, a pilot is subjected to 9 times the Earth's gravitational force. Troy does a last-minute check of his oxygen mask and communication system before he heads out to the plane.
Looking good.
Finally, Troy and his chase team are ready. With 6,000 pounds of bombs attached to his plane, it's time to push the Strike Eagle to the limit. To get where Troy is, young pilots first have to learn the basics. On the edge of the Mojave Desert, at the test pilot school at Edwards Air Force Base, pilots are learning the art of flight testing.
I'm Dan Fritz. They call me Mr. Boney. I'm from Rockville, Maryland.
I've wanted to fly since I was as young as I can remember.
To get into the test pilot school, you need a minimum of 1,000 hours of pilot and command time. You put in a full application package with recommendations. A list comes out, and you find out, hey, I'm going to get into test pilot school. And for about the next week, you're kind of about 2 feet off the ground, kind of really, really happy to have gotten in.
During the one-year course at test pilot school, Dan and his classmates will fly up to 20 different airframes. Everything from a Russian MiG-15 to an American F-15. Test pilot school is where he'll learn the art of precision flying and data collection and get the experience he needs to survive in the high-speed, high-pressure world of the professional test pilot.
What we're going up to do is look at the systems on the F-15E Strike Eagle. Take a look at how they're integrated, how they work in the various missions the aircraft has.
The F-15 Strike Eagle is America's premier jet fighter and one of the most advanced planes the students fly at test pilot school. Dan's instructor pilot explains the new technology.
My name is Lieutenant Colonel Kurt Elkin. I'm an instructor pilot at the Air Force Test Pilot School. We include this particular sortie in the curriculum because of the F-15E's unique abilities and capabilities. Probably one of the only fighters you've flown so far with a glass cockpit, so we'll take a little time and see what you think of that.
The glass cockpit replaces the old fixed gauges with a series of TV monitors.
Fighter cockpits are pretty small, so real estate is a premium. There's so many pieces of information that the pilots need to have at their fingertips at any given time. There's just not room in the cockpit to put it all. And a glass cockpit allows you to customize your cockpit from moment to moment based on what you need right now.
Dan has to get familiar with the Strike Eagle's controls before he takes it up.
I don't have a storage box up here, do I? Okay. Yeah, let me pass this down to you.
First time you get in the cockpit, you strap in, and that's like all the other F-15s you've flown.
Trouble reaching this sucker.
Then you start doing the pre-flight, and the first thing you think is, my God, look at all this that's in here. Then after a while, you're taxiing out, you take off, you start getting a little more comfortable in the plane to where you understand which switch actions do what, and you start to get a real appreciation of why they put this equipment in there and how much more simple your task can be.
For Dan Fritz, piloting the Strike Eagle has to become second nature. In the world of flight testing, a moment's hesitation can cost you your life. Back at Eglin Air Force Airspace, Troy Fontaine begins the pre-flight walk-around on his own Strike Eagle before taking off on the high-speed bomb test.
You want to walk through all the weapons afterwards? Yeah, I'm just gonna do the airplane first, and then I'll walk around and do the weapons.
Troy inspects every inch of the planes. If there are any loose parts or hydraulic leaks, he wants to find them on the ground, not in the air.
0-9, we should be good. The baby go out?
Oh, yeah.
It takes more than just a pilot to make these tests work. Each step of the mission is carefully planned by a flight engineer.
I'm Captain Mike Stevens. I'm a flight test engineer in the 40th Flight Test Squadron. I'm responsible for overseeing all of the weapons tests that we do on the F-15 Zero Day. This blue section you see is a different color than the rest of it because this is where the guidance section or the brains of the bomb is. There's kind of what you'd call almost like an eyeball on the front of this if I were to take this cover off. And this pod, what you see back here, it's called a lantern targeting pod, and it basically shoots a laser beam down at the target that you want to shoot at on the ground. And it's picked up by this eyeball, so when the bomb drops and it's flying through the air, this eyeball will pick up the laser spot. Then the computer section back here will give commands to these fins and fins in the back and guide the bomb toward the ground.
These laser-guided bombs will be a great addition to the Strike Eagle's arsenal, but because they weren't designed to ride on the outside of a plane, Mike has to overcome a major engineering challenge.
Because of the geometry of the airplane, like we got this big round surface here, instead of the air coming straight back here, it tends to be kind of a swirly pattern. Well, if you see this sticking out in the wind and you have swirly air coming around here, you'll see it would have the effect of trying to loosen this guidance section off.
Mike has come up with an easy way to tell if the guidance section shifts during the flight.
We also have the seeker head marked. They've had some problems in the past with this whole front guidance section has rotated from the bomb body itself. So there's a mark here, and a chase pilot's going to be able to look and see if this is moved while we're in flight. That's a bad thing.
If the seeker head came loose on a combat mission, the bomb would have no way of finding its target.
Imagine taking a $44 million piece of machinery 5 miles high and putting it through paces that nobody's ever done before. The feeling of accomplishment, of being able to say, yeah, I can do that, and getting it done is goes beyond satisfaction.
The extra weight of the bombs will keep the F-15's engines working overtime. Troy will have to refuel in midair. A tanker plane is ready to provide the extra fuel he'll need to complete the high-speed test. As Troy taxis to the runway, his chase plane takes to the air. The bomb test is underway.
Clear through the quarter. 40.4 to 180.
With Troy in the air, Mike Stevens goes to the control room to monitor the flight from the ground.
Looks like a lot of fancy equipment, but what I'm really using it for, the most important thing is that I can hear what's going on during this mission.
Mission support, go ahead.
Everything that is said in the test aircraft, I can hear. They're breathing, they're coughing. Any other radio transmissions coming in from either air traffic control or other aircraft in the area. I've got a pilot manual for the F-15E, so if there's some kind of problem, they're usually pretty busy in the heat of the moment in the cockpit. What we can also see on these screens back here, I've got a kind of a situational display where I can see where in the Gulf of Mexico the aircraft actually is. And on this screen is a direct view of what the pilot is seeing in the cockpit.
In restricted military airspace over the Gulf of Mexico, Troy is flying just 500 feet above the water. At this low altitude, the dense air puts the most pressure on the bombs. To stress test the bombs and fins, Troy will push the Strike Eagle to almost the speed of sound.
I'm going to speed soak the airplane down low, about 500 feet. That's the maximum dynamic pressure that's going to be on the weapons and the fins and everything, so that they can look at that and assess whether or not, hey, there's a problem with traveling fast and low. That's the maximum pressure that's going to be on the weapon system and the airplane.
After 15 minutes of traveling down low with the extra weight of the bombs, Troy's almost out of fuel. It's time to go to the tanker for mid-air refueling. There's a problem. The tanker reports smoke coming from behind one of its control panels. On a refueling tanker with thousands of pounds of jet fuel, this is serious news. The whole mission could be in jeopardy. High over the Gulf of Mexico, Troy Fontaine's bomb test is in crisis.
The tanker calls and says he's got smoke in the aft section of the boom operator compartment.
Did you copy?
Just want to confirm, are you RTB?
I'll check out the tanker real quick and then we'll be RTB.
RTB means return to base, but before he does, Troy wants to see if there's any visible damage to the tanker.
He's going up to rejoin on the tanker, not to practice to see if he can get fuel. He's really checking to see if he can see smoke or something coming out of the tanker.
Troy gets as close as he can to look for signs of smoke.
Not quite to the level of an emergency yet, but it's something that can happen.
There's no sign of fire. With the tanker damaged, the test is over. Both planes return to base.
Copy that. Well, that kind of confirms it. We're done for the day.
After hours of planning and preparation, Troy and his team are grounded by the unexpected.
The thing we got done today was 15 or 20 minutes of flying low and fast. And down low is where the densest air is, so that gives the most punishment on the weapon for a sustained period of time.
We're talking about incredibly complicated machines, and all these moving parts have got to work, and a lot of times they don't. So when we get one of these complicated tests off, we have done it so well for so long that I think people forget just how complicated it really is. Flight test is usually a roller coaster ride, and we proved it again today.
Put another quarter in the machine, Daddy. I want to go again. Tanker said he had smoke in the boom compartment back there.
Troy's mission may not have been a total waste. The rough air on the outside of the Strike Eagle damaged the base of one of the fins that steer the bomb. If this happened in combat, the bomb wouldn't be able to direct itself toward the target.
Every mission we fly, we try to glean at least something. Unfortunately, it always seems to be something negative, like maybe the bomb was never meant to be carried on this aircraft after all. Looks like we did get some damage to the bomb after all, even though the overall mission you could call a failure. In the grand scheme of things, it wasn't an overall failure because we did notice some damage on the bomb. We were able to document it. So at least for the future, we know we can expect that to happen.
We burned 20,000 pounds of gas in 1 hour. We sucked an E-model dry with an external fuel tank.
Coming after a sortie like this stuff will pump you up. You don't need to do the weights. You don't need to do the sit-ups or running or anything like that. This will take care of you. Nothing a little caffeine and sugar can't fix. Okay? I'm on the edge, man.
Troy and his team will have to try again later in the week.
Oh, so that's Friday, right?
Well, Friday?
We're going to do this together.
We're going to go finish it.
Yes, make it happen. I can do the approval part.
You know? He has the rank for the approval. You have the connections to get it done.
Notice how the engineers really run the programs here without being leaned on by the big guys.
If they came to me tomorrow and said, Troy, you're done flying, you'll never fly again, I would still count myself probably one of the luckiest guys alive.
A test pilot has to learn to keep his cool, especially in the twisting, turning environment of an out-of-control plane. Spin testing teaches a pilot how to recover his plane, but first he has to throw it out of control.
Have a great day.
Okay, talk to you later.
All right, bye-bye. See ya.
Later. Bye-bye.
I'm Captain Chris Dobb. My hometown's Atlanta, Georgia. I can't remember a time where I didn't want to fly, ever since I was a little boy. Everybody goes into this job knowing that there is a certain amount of risk. You do everything you can as a pilot to minimize those risks and to be ready for your flight. If we can't minimize the risk and do things safely, then we'll find another way of doing them. I am a creature of habit. You know, I tend to do things the same way every time, put my G-suit on the same way every time, get prepared in the cockpit, go through the same checks the same way every time. And that kind of gets me in the mood, gets me in a rhythm, gets my game going so that when I get out to the runway and get ready to push it up, you know, I'm ready.
To complete the flying quality stage of his test pilot training, Chris will have to take his Air Mach Impala through the dangerous spin test. His instructor pilot is in the back seat.
60%. Okay. We'll be rotating at 80, and remember to try to get 200 as soon as possible. Okay, steer with the brakes. Nice and gentle. Nice and gentle. Coming up. Okay. Nose down a little. Tap the brakes. Brakes. And landing gear up. Gear coming up. Okay, just fly level. And 120, flaps are coming, and I'll just get them from here.
Be totally focused on what you're doing, particularly in a high-performance airplane, and you're not totally focused on what you're doing. That's when you can get yourself into trouble.
At the target altitude of 25,000 feet, Chris is ready to throw the plane out of control.
Just let me know when you're inbound. 250 and below. Copy 250 and below. You can set up for your phase A stall. Okay, we're 180 slow and headed at this speed.
First, Chris has to slow the plane down until it stops flying.
100 knots.
As he approaches 100 knots, the Impala starts to shake.
A definite increase in buffet there. Steadily increasing through 95. There's a pitch buck. There's your stall. 92, that's the stall. There we go. Full controls. Okay. Full right rudder. Starting at 22.2. 22.2. There's one turn. 22 and 110.
This is the moment that separates test pilots from the rest of us. With his plane tumbling out of control, Chris remains calm. With the ground rushing up at over 200 feet per second, he's constantly noting the altitude and airspeed of the plane.
30, 3 turns, 21 and 140, 4 turns, 20.5, 160, 5 turns.
Chris Dobb keeps his cool. He pushes the Impala's rudder in the opposite direction of the spin and brings the stick forward to neutral.
And 1 turn to recover.
At 18,000 feet, Chris regains control of the Impala. After falling almost 5,000 feet in just a few seconds, Chris's test pilot training pays off.
To me, it's just better than any amusement park ride I've ever been on. It's just a rush being up there.
At Edwards Air Force Base, pilots are testing more than airplanes. The Joint Helmet-Mounted Cueing System projects vital flight information directly onto the pilot's helmet visor. Developed to work in conjunction with an aircraft's weapon system, the new helmet will eventually allow pilots to aim their weapons by simply looking at the target.
My name is Captain Dan Marticello. I'm a flight test engineer here at Edwards Air Force Base.
Eagle House, Captain Marticello.
My primary project is the Joint Helmet-Mounted Cueing System. The helmet display unit is modular. It pops right off the helmet like that. You can see where the connector is that plugs into the helmet shell itself. Then you have some electronic circuitry. You have the cathode ray tube that generates the display and its associated optics. You have the uplook cursors, a camera so we can, after the flight, see what the pilot was looking at, and of course the magnetic tracker that detects where the pilot is looking. In a combat environment, we can expect up to 9 Gs. So then you could now understand that a helmet that weighed 2 pounds now weighs 18 pounds, and would be a significant amount of weight to be pushing around on your head.
Fitting this sophisticated technology into a lightweight package presented a unique engineering challenge.
In order to keep the weight of the helmet system down, they've used a very lightweight composite material. The other thing is they've constructed the electronics out of as lightweight material as possible in order to make the entire system light enough to be usable in a high-G environment. The joint helmet mounted cueing system allows us to aim our weapons without having to turn the aircraft. Rather than having to turn the airplane to line up the missile with the enemy aircraft, I can now just turn my head. It makes your platform a lot more lethal.
At the Naval Air Warfare Center at China Lake, California, pilots are testing one of the weapons designed to work with this revolutionary new helmet-mounted cueing system, the AIM-9X missile.
My name is Lieutenant Terry Barrett. I'm the AIM-9X project officer here at the Weapons Test Squadron. And we are developing both the AIM-9X and the Joint Helmet-Mounted Cueing System to work together to schwack the enemy.
Before he can schwack the enemy, Terry has to test the new missile's guidance system and its superior tracking ability. The AIM-9X is the latest generation of the Sidewinder heat-seeking missile carried on the wingtip of the F-18. To test the new missile's guidance system, Terry needed to shoot down a real plane. An unmanned F-4 Phantom jet was selected as a flying target.
The guy who flies the F-4 is actually sitting in a cockpit in range control where all of our data is taken. There's a camera mounted on the front of the F-4, and he actually looks through that camera as if he's in the airplane and takes it off and flies it. The day of the flight, we were all pretty excited.
All right, 112, please. This is the helmet with all this gizmo stuff right there. This is what makes it work.
A modular plug connects the helmet to the F-18's instruments.
We now have the ability to see our airspeed, our altitude, our G, everything right there on the helmet as we look around. And it's just a fantastic tool.
All right, then.
Terry's working toward the day when he'll be able to use the helmet to aim his weapons at the target.
The helmet will be integrated with the seeker head of the AIM-9X missile, so that wherever you look, it will move the seeker head around. So if you look up at the target, it will move the seeker head up. And now what you can do is you no longer have to point your airplane at the enemy to shoot him. You can really point your eyeball at him, lock the missile on, and shoot.
Before the helmet and missile can work together, Terry must first test the AIM-9X and its new guidance system.
As you start the run, you're very excited. You're nervous, your palms get sweaty, and you're full of anxiety. But as the maneuver starts to take place, you start concentrating so hard and working so hard to make sure that everything is correct, that when you actually pull the trigger, you're just so in tune with what's going on that you really don't feel any of that nervousness.
With the AIM-9X on the wingtip of his plane, Terry takes to the air to begin the first ever guided launch against a real flying target. Desert landscape of the China Lake test range, Terry Barrett is at the controls of his F-18, ready to begin the first ever guided launch of the AIM-9X missile against an unmanned F-4 Phantom jet. The F-4 pilot sets up the target plane at 17,000 feet, flying at Mach 0.7, almost the speed of sound. To properly test the AIM-9X, Terry has to fire from an angle that's too extreme for a regular Sidewinder missile's guidance system. Finally, range control gives him the go-ahead. It's the moment they've all been waiting for. Terry gets ready to fire. Tracking cameras and radar monitor every moment of the test.
5, 4, 3, 2, 1, Mach 2. And away. Standby for intercept.
The great thing thing about shooting at a live target is once that trigger is pulled, your job is done. If you've done everything okay, you're no longer worried about screwing up. Now you can sit back and enjoy the show. We saw the missile come off my airplane, do a hard left turn, and where we would have been successful, even if the missile would have come close, the missile had a direct hit with the QF-4. It went right into the side of the airplane, blew a huge hole in the wing. The jet flipped over, turned into a giant fireball, and a lot of the screaming you could hear was us. We were all pretty excited because there was no doubt that it was successful. There was no data analysis or anything to prove. We had a huge fireball, and it was awesome. There's thousands of people working, millions of dollars being spent, and we're the lucky ones that get to actually see it up close. And we recognize we're just a member of the team, but we're the member of the team with the best seat.
Stand by for splashdown, Low-Tech. There it is.
You can look at all the data you want, but a huge fireball in the sky is, you can't beat it.
Back at test pilot school, Chris Dobb gets ready for the next stage of his training, the qualitative evaluation program.
Try to fly as many airplanes as we can while we're here in the school, and every plane has something to teach you.
A test pilot has to be ready for anything. To make sure he's seen it all, the test pilot school will put Chris in as many different planes as possible to give him the experience he needs to stay alive. The MiG-15, once the terror of American pilots in Korea, the MiG was the backbone of the Soviet Air Force in the 1950s. Today, it's a museum piece, but one that still works. Flying a vintage warplane is dangerous, even for the most experienced pilot. Instructor John Penney explains the risks.
They say that there's a high probability of some trauma to the back if you have to use the ejection seat. If the air loads are not enough to get you to separate from the seat, you've got to push away from the seat and get out of there. So I need to know from you guys right now if anybody has any second thoughts about going to fly with these limitations on the seat.
Battling the controls of the foreign fighter, Chris can see firsthand the limitations in performance that made the MiG obsolete and get some of the insights he'll need to help design the planes of the future.
And a particular interest in the MiG-15 is that this airplane has characteristics of jet fighters that were designed in during the first generation of jet fighters right after World War II.
A lot has changed in the world of aviation over the last 40 years, and Chris has to adapt to the shortcomings of a cockpit frozen in time.
There's some adverse handling qualities, if you will, that things they cannot see in the current generation fighters because of all of the fly-by-wire, computer-controlled technology of the flight controls.
It's a different approach to flying. Everything about it, taxiing the airplane, the flight controls, where the controls are located in the cockpit, it's just totally different, the latest in early 50s technology.
The MiG's handling and performance is lacking by today's standards, but Chris pushes the old warplane as far as he can.
The airplane starts rocking back and forth, like it really doesn't want to be there, and so eventually you gotta slow down. It was just way cool being up there.
Graduation day is around the corner, but Dan Fritz still has one final exam before he can enter the world of the professional test pilot.
We all have to do a test management project, and ours was a deep stall test on the F-16B.
Captain Colin Miller is one of the other pilots involved in the test.
The graduation exercise for test pilot school is really running a test program from beginning to end, and they call it a test management project. Our specific one was called Have Ballast, and we called it that because we're trying to make an F-16 depart controlled flight and basically go into a spin. The F-16 has a fly-by-wire flight control system that tries to prevent the airplane from departing controlled flight. And we did some tests to see what happens when you actually force the airplane to go out of control.
The F-16's computerized flight control system is designed to help the pilot keep the plane under control. To perform their test, Colin and Dan had to disable the flight control system and modify the structure of the plane to throw it off balance.
In order to do that, we had to move the center of gravity of the airplane aft, and we did that by putting a bunch of lead in the tail. So we called it half ballast.
First off, we start at an altitude where we know we have plenty of time to recover the aircraft.
At 30,000 feet, Dan and Colin begin the test.
We zoom the aircraft into a near vertical climb.
And in the F-16, the seat is inclined at 30 degrees. So actually, you're past the vertical as you're sitting in your seat.
Pull the throttle idle. If you don't go to idle, you're not going to run out of airspeed. As we climb, the airspeed diminishes down to a point where the wing is no longer going to fly.
Warning, 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 warning. The aircraft has a number of warning systems to keep the pilot from going out of control, going straight up. So you'll hear the airplane start to talk to you. There's a voice that starts saying warning, warning, and caution to tell you that you're about to go out of control.
Warning, 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 warning.
The F-16's computer warns the pilot that he's losing airspeed and is about to stall. Colin has to ignore these warnings to complete the test.
So we'll silence those warnings and keep the airplane in that attitude until the airspeed bleeds off to 0 knots. And at that point, you're just hanging in the air, and you're just sitting there, nothing's moving. And then the airplane just starts falling like a rock. And it may oscillate back and forth, it may flip upside down and fall inverted. But the bottom line is it's no longer flying, it's falling. And you'll get rocking back and forth in the cockpit. If you're inverted, you feel like you're strapped in a chair that someone nailed to the ceiling. You're just hanging on the straps, being knocked back and forth.
Oh yeah, look at that.
Now that Colin and Dan have forced the F-16 out of control, they have to figure out how to get it back. It's the final exam for a student test pilot. At over 300 feet per second. As the ground rushes up to meet him, he fights to regain control before reaching the bailout altitude of 10,000 feet.
Up to the horizon and back down.
At a certain altitude, we need to recover the airplane. We have a switch in the airplane that we can throw that takes the automatic flight control system basically out of the loop and gives the pilot direct control of the flight control surfaces.
Without the automatic flight control system to help recover the F-16, Colin has to use his test pilot training to manually get control of the plane.
What we do is we rock the plane out of the deep stall condition, kind of like you would rock a car stuck in mud out of the pothole, push it repeatedly until it gets enough momentum to get out of the hole. We do the same thing with the plane and rock it until the nose is pointed at the ground.
With the nose of the plane pointed down, the airspeed increases toward 200 knots, and the F-16's wings begin to provide the lift necessary to maintain controlled flight.
At that point, we keep it pointed at the ground, the airspeed increases, and then we're flying again and we can recover from the dive.
It was all fun up through the flying, then we had to come back and report on it.
This is an F-22 Raptor, the hottest new fighter plane in the Air Force. In fact, the hottest new fighter plane in the world. If you're a test pilot, this is where you want to be, in the driver's seat, like F-22 pilot Paul Metz.
I can still remember the first time they called me in to look at the prototype. Here was this model of an airplane that didn't even look like any other airplane I'd ever seen before. And I was immediately enthralled by it, and never thinking that I'd get to fly it and make the first flight on it someday.
In 1990, there was a fly-off competition between two prototypes to decide which plane would become the new tactical fighter for the Air Force. Paul Metz was one of the pilots.
The conclusion of this period of time where we had the competition between the two prototypes, the Air Force selected the YF-22 to become the F-22, the next air superiority fighter for the Air Force.
Once a prototype plane is selected, it has to undergo rigorous testing before it's ready to go into production.
Flying a test-bed airplane is not like pulling your 747 out on the line at LAX, putting people in and going flying. It's a much more complicated endeavor, largely in part because it is not just the airplane. We have a tremendously complex data system that gathers information on the flight. We telemeter that back to a ground station. We have chase airplanes. We have air refueling tankers. We have tracking radars on the ground. So it's literally a cast of thousands of people that help put a mission together. Modern fighters have a tremendous amount of capability. They can turn hard, they can go supersonic, have tremendous thrust, kick you in the rear end and push you out there. And the F-22 is a step above that.
The F-22 uses thrust vectoring technology, allowing the pilot to aim the thrust of the engines. This enables the F-22 to turn harder and fly at extreme angles, well beyond the capability of a conventional fighter like the F-15. To protect the pilot in this extreme high-G, high-speed environment, innovative life support equipment is required.
This particular set of flight gear was actually developed for the F-22, a bit unique, and the reason is because the F-22 can actually reach G-loads much quicker than conventional fighters, so quickly that the pilot would actually pass out before he even realizes that he's being impaired by high G-loads. So this gear is meant to give him just a little bit more of an edge in combat.
The F-22's handling pushes the limit, but its real innovations, which are classified, lie hidden beneath its skin.
The real secrets of this airplane are in things that actually you can't see or we can't show you. The stealthy characteristics of the airplane, the ability to travel around and not be seen or make it very difficult for the enemy to see you, is probably the biggest tactical asset that the F-22 has. The other piece that you can't see and we can't show you are the tremendous avionics in this airplane. That increase in computer capacity and computer power that's occurred in the last 15 years has been transformed into the F-22. Makes it a giant internet kind of device. Its web browser goes out and samples the world around it, brings in tremendous amounts of information. Gives that to the pilot in a very intuitive, very understandable form. I would hate to meet another F-22 pilot in a current generation fighter. It's cool. There's no question about it.
Most of the street signs here at Edwards are named after guys that have lost their life in test. And while we all acknowledge that, that's kind of our tribute to them and the sacrifice they made. None of us really think it's going to happen to us. You know, we plan for it in all our safety planning to make sure that it doesn't happen to us. The road signs are reminders to do it right.
It's graduation day at the test pilot school.
We'll now graduate Class 98 Bravo. Captain Christopher P. Dobb, test pilot, United States Air Force.
Gonna try and become an expert in the C-130 and then learn about the newest version, the C-130J model, which I'll be doing some testing on here at Edwards.
Captain Colin Robert Miller, distinguished graduate, test pilot, United States Air Force.
I love flying. I love going out there in a jet and yanking and banking and having a great time. I like solving problems, and I like having the opportunity to make an impact on the future of Air Force aviation.
Captain Daniel Joseph Fritz, test pilot, United States Air Force.
I'm looking forward to the next few years working the B-1 armor test. The first thing for me is to learn the B-1 as it is today. After that, the possibilities are wide open. We don't really know where the Air Force will send me. And that's maybe some of the excitement of it.
Responding to you, there's a chance that I'm kind of overwhelmed by events, so try and get my attention. Use first names, all right? Troy, you're in a right spin. What I want to do is if we have imminent signs of recovery passing through 10,000 feet, we'll hang with the aircraft till 6. At 6,000 feet, what I want to hear from you is Troy, eject. Troy, get out of the airplane. Use my first name and get my attention. Okay, let's not use the bail out over the radio. All right, and at that point, we'll give the jet back to the government.
The anti-G suit is used to basically pump blood back up into our brains. It doesn't make us any smarter, but it's under high accelerations, high Gs, the blood drains from your brain out of your head and pools in the lower extremities, mostly the liver and your upper legs.
Shouldn't have that big sandwich for lunch.
Yeah. Is that your G-suit?
In sharp turns and steep dives, pilots experience gravitational forces many times that of gravity on Earth. Pilots can black out at the controls when this pressure causes the blood to drain from their brains. Known as G-lock, this poses one of the greatest physical challenges for the fighter pilot.
What happens is there's bladders in the G-suit and the hose hooks into the airplane, and getting certified on the drop them off of the F-15E, the Strike Eagle.
The F-15 Strike Eagle is the latest version of the F-15 fighter, the workhorse of the Air Force for the last 25 years, while a regular F-15 is designed for air-to-air combat. The Strike Eagle is capable of both air-to-air and air-to-ground missions. The GBU-27 was designed to ride inside the belly of an F-117 stealth fighter. The challenge for Troy and his team is to carry the bomb safely in the extreme wind conditions on the outside of the Strike Eagle. First, Troy has to brief his crew on the dangerous mission.
Out of control. Let's talk about that for a second.
A chase pilot in an F-16 will follow Troy every step of the way, both to note the effects of the wind on the bomb and to help out in case of an emergency.
It looks like we're departing the airplane if something goes wrong. Try and be a walking, talking altimeter to us.
Every year, pilots are killed when they push their planes beyond the limit and lose control. With an untested weapons configuration, there's no way for Troy to know how the plane will respond. If he becomes disoriented and can't read his instruments, his chase pilot will have to warn him if he's getting too close to the ground.
Remember, as a chase pilot, try and keep the airplane, the spinning aircraft at that point on the horizon. All right, so that you've got an accurate altimeter to us. If I'm not
what's never been flown, putting their lives on the line to push the limits of aviation and ensure our air superiority in the future. At Eglin Air Force Base on the Florida Panhandle, professional test pilots are doing some of the most extreme testing done to airplanes.
My name is Major Troy Fontaine. I'm the chief test pilot in the F-15E at Eglin Air Force Base. We take the aircraft or the weapon system or a combination of the two, and we put it through its paces for the first time. Somebody's got to do it for the first time, and that's our job.
At 37 years old, Troy has logged thousands of hours in over 25 different aircraft, flying as both a fighter pilot and as a test pilot.
A fighter pilot very much is an attitude, a killer instinct. You need to turn that off a little bit when you become a test pilot, and sometimes that's hard, very hard in my case, as opposed to going up and killing somebody. The mission is to take an airplane up and do something with it that nobody's ever done before.
This mission is to fly with laser-guided bombs that have never been used on the F-15.
This is a GBU-27. It's a 2,000-pound laser-guided bomb. And we're getting, as you pull G's, it senses that acceleration. It inflates the hose, inflates the bladder, pushes against our livers and our upper thighs, and pushes the blood back up into us. It gives you about an extra G of tolerance. So if you normally black out at 8 Gs, now you can pull 9.
G stands for gravity. In a 9G turn, a pilot is subjected to 9 times the Earth's gravitational force. Troy does a last-minute check of his oxygen mask and communication system before he heads out to the plane.
Looking good.
Finally, Troy and his chase team are ready. With 6,000 pounds of bombs attached to his plane, it's time to push the Strike Eagle to the limit. To get where Troy is, young pilots first have to learn the basics. On the edge of the Mojave Desert, at the test pilot school at Edwards Air Force Base, pilots are learning the art of flight testing.
I'm Dan Fritz. They call me Mr. Boney. I'm from Rockville, Maryland.
I've wanted to fly since I was as young as I can remember.
To get into the test pilot school, you need a minimum of 1,000 hours of pilot and command time. You put in a full application package with recommendations. A list comes out, and you find out, hey, I'm going to get into test pilot school. And for about the next...
You're rocketing along at 1,000 miles an hour. The plane is out of control. you're spiraling toward the Earth. For most people, it's a nightmare. For a test pilot, it's a way of life.
What we do is we take the aircraft or the weapon system or the combination of the two, and we put it through its paces for the first time.
There are more opportunities to make catastrophic mistakes in this line of work.
Test pilots propel 10 tons of steel and 4,000 gallons of jet fuel through the sky at speeds of more than 1,000 miles an hour. They do it every day, at every angle, in every circumstance. They push state-of-the-art technology beyond known limits, putting years of research, millions of public dollars, and even their own lives on the line.
Somebody's got to do it for the first time, and that's our job.
Imagine you're breaking the sound barrier. 500 feet off the ground, 800 miles per hour, and cheating death every second of the way. It takes special individuals, people who are ready to face the unknown and take themselves and their plane to the limit. Risking it all, test pilots try what's never been tried. Fly